Okay, so welcome everybody to my talk about domain-driven design, a complete example. So there will be the possibility to ask questions. There is a QR code there, and it will take you to a website where you can choose the Cinema 7, that's this place, and you can ask questions, and I'm going to see them here on the screen, and I'm going to answer them as soon as possible. A few words about myself. My name is Eberhard Wolff. I'm with SwagLab. SwagLab is an e-commerce consultancy, and I'm doing architecture things there. Yeah, and I do have a homepage, so take a look there. And I've written a few books about microservices, about continuous delivery. I'm a regular conference speaker, and I also do a stream about software architecture. So why this talk? Well, there is a lot of tools if you look at domain-driven design, and the question is which are really useful, and how can you combine them? So that's what I'm going to answer. So we are going to go through an imaginary project and see how we can take all the different tools of domain-driven design and make use of them. The whole thing might look like a waterfall because we are going from more abstract to more concrete techniques, but it's certainly not supposed to be a waterfall. So you need to work in iterations. So everything that I present here should be done in iterations, and you can repeat the step at any time that you feel comfortable with. And you need to change the level of abstraction throughout your project. So it's very likely that whatever I'm going to present here, you're going to do it multiple times because, you know, this is software development, this is a learning process. So you will never get it right the first time. So you need to iterate and iterate and iterate. And actually, there is a talk of mine that claims there is no such thing as a waterfall model. So I feel very deeply about not doing the waterfall. So let's imagine that we have some domain, and we want to get an understanding about how the domain works. So on a very abstract level, we need to understand what is going on in our domain. And I would suggest to use event storming for that. First question is, why would you do event storming? Well, the problem is there are the domain experts, and there are the software engineers. And the domain experts, by definition, basically understand the domain, while the software engineers know how to structure knowledge so it becomes software. And you need to have both to come up with any sensible system. If you just listen to the domain experts, they don't know how to structure this stuff. That's what we as technical people have a lot of interest in, and what we can do quite well. And well, therefore, we need to collaborate. So the question is, how do you get that domain knowledge that is in the heads of the domain experts? How do you make software out of that? And there is another problem. The problem is that the domain experts don't know any formal methods. So if you talk to them about architecture diagrams, about anything that we do as technical people, usually they can't really follow, and probably they shouldn't because they are domain experts, they are not software engineers. And we don't know the domain. So somehow we need to have some way of collaboration to come up with a shared model to understand the domain and work on it. And this is where I think event storming comes in. And the way that this works is that you write down an event in the past. So it is something that has happened. At least you have to have a noun and a verb. The verb in past tense, because it's something that has happened, and you write it on an orange sticky. So something like order accepted, right? So I am actually going to talk about an e-commerce domain, not because I'm a specialist in that regard, but rather because we all have a rough understanding about how e-commerce probably works, right? We have all been there and ordered something at some e-commerce site. The nice thing about this is that it takes basically a slide to explain this, so it's something that I suppose domain experts should be able to do, because it's not really high-tech, it is something that is quite easy to do. So if you do that, you do it in multiple phases. The first phase is chaotic exploration, so the idea is to create as many events as possible and put them on the wall. And if you look at the events here, the orange stickies, then they should be in a timeline. So what you're going to do next is you're going to enforce the timeline. So you might remove duplicates. You might have a discussion about whether these things are really needed to do the next event, and so on and so on. So this is what it looks like. And then you can introduce even more order in these sets of events. So you can have parallel activities, for example, and you would separate them, and then you have a swim lane. So for example, here's a swim lane that deals with invoicing, right? So it writes an invoice after we've ordered something. And here is another swim lane that deals with delivery. So we have two parallel things. They are somehow interconnected because obviously you want to only deliver stuff if it's paid for, but most of the stuff is actually in parallel, and you can identify that because there is, well, you will actually, in my experience, it comes quite natural for people to separate stuff that is done in parallel and is not really that dependent on one another. The next thing that you want to do is to identify pivotal events. And I guess you can do a whole talk about what pivotal events actually are. So there are some heuristics to identify them. I have given the heuristic that in my opinion is, or that helps me the most. So somehow the world is different afterwards. So let me give you an example. So here is the order accepted event that we've already spoken about. And afterwards the world is different because afterwards you can only cancel the order, while before there was the shopping cart and you would just put stuff in and out. The shopping cart, for example, is gone after you've accepted the order, right? It's dead, it's not there anymore. So the world is quite different. So there is a new object, the order, there is an object that has been replaced or is not there anymore, which is the shopping cart. So therefore the world, I would argue, is actually different. And here is another pivotal event. So if the parcel left the warehouse, then there is no way to keep it back, right? Because so at that point, DHL or whoever is responsible for delivering the parcel will eventually deliver it. So there are certain things that you can't do anymore, right? I mean, there is no way to say, okay, this is not going to leave our warehouse. So for example, you might want to make sure that the stuff is actually really paid. So, you know, you can maybe pack it up and put it somewhere, but it doesn't leave the warehouse until it's actually paid for, because then you can't easily get it back. So these are pivotal events. Afterwards, the world is different and things have become different. Why is this a good idea? This is a low-tech approach, so it's easy to understand for domain experts. As I said, it's basically around stickies and, you know, putting something on there that matters to them and put it in the past. You can have quite a lot of people working on that model in parallel. So it's easy, you know, in a room like this, you can have one of the walls and put stickies up the wall, and you can easily have 10 people also working on that in parallel and putting up events. Eventually, in chaotic exploration, of course, eventually you will clean it up and, you know, you will have that timeline, and then you will have a shared understanding about what's going on. And there is a third thing, which is it becomes obvious how people interact. So if there is some person who knows a lot about a specific piece of the whole process, it will become obvious because that person will only work on that part. If there is someone who wants to control everyone, well, it's going to be obvious, right? Because that person will try to control everyone in the event storming session. There are quite a few seats in the very first row if you want to join. And this is often forgotten about. I think in software development we often focus on the artifacts, like in this case the event storming and the events and the stickies, but really it's also about collaboration. Challenges, well, you need to get the right people. If you have users that actually use the system, they might not have the vision and the context to understand why this system was created in the first place, why it's valuable to the overall organization. And on the other hand, if you just stick to managers, then they will not understand how the day-to-day work works. And somehow you have to have people that have some kind of vision, and you will have some kind of people that have some kind of vision, but still know how day-to-day work works. Maybe you can, but in event storming you can also have collaboration of multiple people. So therefore, it's not so hard if you have different roles to get them all together. And the other problem is, as I said, only everyone will only understand a part of the logic, so it's hard to figure out anyone who actually understands everything about the whole system. As a result, there will be a common understanding of the domain. So therefore, there will be a model of the domain, and it has to be tweaked and before it's implemented. So the goal is not to have something that you can directly put into code, but it's really about having a shared understanding. So this is a good foundation to put something into code, but still there are some steps to be done here. And as I said, roles and collaboration in the project become obvious. There is a question which is is a pivotal event something that then requires a compensating action? Maybe, right? Because then things will be different, but that's not the point. As I said, it's about the world change. New stuff comes into play, old stuff is not there anymore, so it's pivotal, it's very, very different afterwards. The compensation basically means that you somehow have to revert it afterwards. That might not be the case, right? I mean, at the end of the day, we want to deliver stuff and write invoices, and compensations should be the exception, not the norm. But yes, because the world is different, then there might be compensating actions needed at some point. Okay, so where are we in the process now? We have had that meeting with the business experts, and this huge meeting where everyone comes together and we develop a shared understanding about what's going on in our domain. Now the question is, what do we do next? And the next thing that we can do is we can come up with bounded context. Why bounded context? We somehow have to split our domain into something coarse-grained. We have to have something where we say, okay, this team is going to do this and that team is going to do that. Or, we will have this microservice, or we will have this Java package, something like that. So we are looking for something that might be assigned to a team, but a team might still work on multiple bounded contexts because, well, if this is small and there is not too much to be done, then they can certainly work on quite a few. But you should not share bounded context between teams, because chances are that then they step on each other's toes. So what is a bounded context? I like the name because it quite clearly expresses what this is about. So it's about bounds. So there are boundaries. And what is inside this boundary? Well, there is a model, so it's code. And there is a ubiquitous language. So a language that is everywhere. Which leads to the question, where is that ubiquitous language? What does it mean for a language to be everywhere? Well, it's something that we should have in the code, that we should have in the database, and that also software engineers or domain experts should talk about. There are some obvious things, a customer, an order. There are some not too obvious things. So in my project, we currently have something that is called SOPA. SOPA, anyone? Obviously, so that's other partners, sonstige Partner. And you wouldn't know because you're not part of the project. So it's truly something that is that they only know in that project. And I'm not going to explain what it is, but in that project, it makes a lot of sense to have it in the code somewhere to say, okay, this is one of these SOPAs, to have it in the database, and because it is something that I can explain to a domain expert. So things become much more easy because then you can have a code that directly represents what's going on in the domain. So in our example, we would probably have something like an invoicing process and delivery, as I said. And now the fun part starts, and the fun part is that I ask you to build something for invoicing. Well, so we are going to have products, we are going to have customers, and whatever. Okay, cool. So let's take a look at this. So we will have the customer, and the customer is the one who pays the bill. So let's imagine that I'm buying a laptop for myself, but SwagLab is supposed to pay. So the customer here is SwagLab GmbH in Hamburg. And this is what it should say on the invoice, right? It should say SwagLab GmbH, Simon von Utrechtstraße in Hamburg, obviously. Now, the customer concerning the delivery should be myself. I live in Kaiserslautern near Ramstein Air Base, so that would be the customer that the stuff is delivered to. And I certainly hope it makes it to my place and it doesn't go to Hamburg. So those are actually two different things that have the same name. And now we can easily reason about this because we don't have to say the customer. We can say, okay, we are talking about the customer in the context of delivery or the customer in the context of invoice processing. How do you end up with these bounded contexts? Well, if we look at what we've created so far, I would argue that we can identify candidates for bounded context. So that would be the area between the swim lanes and the pivotal events, but not all pivotal events separate bounded contexts. So I would argue that this might be a bounded context, this might be a bounded context, and this might be one, but I don't think that the parcel leaves the warehouse is something that justifies a completely different model and starts a completely separate set of terms and ubiquity concerning the ubiquitous language. Now you might think, okay, why do I think so? Because that's my impression from the domain. And you might have a different one, which is great. And actually, it's a good point to see that there are different interpretations of the domain. And we can have that discussion, right? We can have that discussion whether this is really something where we will have a different bounded context, because actually there are things that change if the parser changes leaves the warehouse. We are not interested in the products anymore. At that point, the products don't matter. It's just about the parser that goes out. So maybe you want to have a different model that doesn't talk about the products anymore, but only about the parser. But that's up to you. And I made my decision here. So we will have order process, invoicing, and delivery process. That's what I decided. And there is a reason why it says candidates, right? Because it's not like there is a purely mechanical task that says, okay, we're going to take this area and it's called a bounded context now. And for that reason, I've spent another slide explaining some things that I'm not sure about. So let's imagine that we want to reimburse people because they return products. Are we going to do that with the same model as the invoicing? I don't know, maybe, because it's compensating, maybe not. We should have that discussion. Would we handle returns with the same model as the delivery process? Same point. There is a really technical people should ask ourselves is, if we have a model that already covers X, so invoicing, for example, is it also a good idea to use this? If we have a model that already covers X, so invoicing, for example, is it also a good idea to use that for Y, for, in this case, reimbursements? And those are the interesting discussions that you can have, right? So why is this great? Because it structures the domain logic, which I believe is quite important, and we are talking about domain-driven design, right? So by definition, this is part of domain-driven design. Requests are probably local to one bounded context because there is a separate functionality there. And changes too, right? Because if I want to change how stuff is delivered, where there is the delivery bounded context. And that's not a coincidence, it's by design, because we have stuff that separates the whole thing into different parts of the domain. So I would argue it's a great architecture because it supports typical changes. So that's the reason why you probably want to do this. What's next? Core domain. So the core domain is the motivation of for the product. So the question is, are swimming lanes natural indicators of bounding context? As I said, yes. So it would be something. I mean, that's basically what I was trying to say right in this slide here. So these are good candidates, but you have to think about that, and you have to look a little bit closer, and there might be exceptions. So I wouldn't be surprised if somewhere here there is some interconnection between those two, because you want to make sure that stuff is only delivered if it's paid for. And then we have some, maybe in the delivery process, there is one step that you would rather do with the invoicing model, and these are the things that you have to think about. So it is a good indicator, it's a good starting point, but then, the design part starts, the actual design part starts. But indicators, so the original question is, are swimming lanes natural indicators of bounding context? I would say yes, they are, but indicators. It's not like, paint those boxes and then you're done. So core domain, it's the motivation for the project. And for this part, we want to reduce the complexity of the model and focus on the maintainability. So basically the point is there is some part of the system that is important, and this is what we want to focus on. So we have order processing, invoicing, and delivery process. And I would like to ask you to identify the core domain. So there are 4 options: order process, invoicing, and delivery process. And the 4th option is I don't know, or I'm not sure, right? So who would think that order processing is the core domain? Anyone? That's a few. Who would think that invoicing is the core domain? It's like 5, 6. I would believe half of what we have for order processing. What about delivery process? 2. Okay. Usually I get even more people arguing that order processing is the core domain, and I'm sorry, because this is sort of a trick question, because actually, who isn't sure? I forgot about that. That's actually, that's good. So those were even more than for order processing, because I would argue that this is a question that we cannot answer unless we talk to the domain experts. And in our case, it's about delivering quickly and reliably. So the core domain is the delivery process. The rest are just generic subdomains or supporting subdomains and stuff that we don't want to focus on. And this is something that I decided as a domain expert. It's not the call of some technical person. Of course, the technical person would need to translate it, but it is a good idea to answer I don't know and ask someone. I think that's the right thing. Now what this means is that we somehow have to focus on the delivery process. And usually, so for example, we would like the order process to support the delivery process, because there is an interface here, and they need some information from the order process. So therefore, it would be a good idea if they have some kind of priority here. So we are talking about some setup of some organization, and this is usually where at least the original domain-driven design book talks about strategic design. But I'm rather going to talk about team topologies, not because it's a new thing, but rather because I would argue it's simpler than strategic design and probably easier. It's simpler, more powerful, and therefore probably easier to adapt and makes more sense. So why team topologies? Because somehow teams need to collaborate. As I said, it's probably not too complex. It's intuitive. I believe the ideas are intuitive, but that's up for you to decide. And it's also more, how shall I put it? It's more about what happens out there in the wild. So for example, it doesn't just say, there is one team that deals with one bounding context, but it actually acknowledges that there are more fracture planes than that. So fracture planes are one way to separate teams. Somewhere, I don't know, in Hamburg, for example, then there are 2 locations, and it probably makes sense to have 1 team per location, because they can, for example, then there are 2 locations, and it probably makes sense to have 1 team per location, because they can, they can go in 1 room and talk to one another and have direct communication. If you ignore that, and if you say, okay, we're just going to have people work together for other reasons, then every team will be distributed across Hamburg and Kaiserslautern, and I don't think this is it's obviously the better choice. So to have local teams and to say, okay, you are in 1 team because you're at the same location, probably makes some sense. And it covers more team types than just development teams. So which types of teams are there? Well, there are streamlined teams. So streamlined teams are teams that somehow provide value to some kind of persona. Maybe they care about a product, whatever. And they are called streamlined because they cover the whole process from requirements until it's in production. So this is actually the stream that we are talking about here. Then there are enabling teams. Those are specialists for specific things that are going on. Then there is a platform team, which is probably intuitive, right? That's the team that cares about a platform like Kubernetes or whatever you have. And the complicated subsystem team that provides some kind of help for some specific challenges. So we can apply that to our example. So we have invoicing here, so that's a streamlined team. Fracture plane is bound in context, and we have a few other streamlined teams for the other 2 bound in context. Then we have the delivery optimization complicated subdomain. So that's as delivery is something that is the core domain. We have advanced algorithms that are complicated, and AI and all that stuff is in there. And those people here, if they also care about that, then things become complicated because they would need to care about the UI, the persistence, what is a customer in this field, and talking to DHL, and also doing the algorithms. Well, that's probably too much cognitive load. That's the expression that Team Topologies uses. So we externalize that to a specific team, and we provide this as a service, which basically means there is an API. So they will provide some kind of code with an API that can be called by the delivery team. Then there is the platform team that provides Kubernetes and some kind of continuous integration, which again would be provided by some kind of, well, like the X as a service is like infrastructure as a service, platform as a service, and so on. So here the same thing. There would be a website to say, okay, we need another CI pipeline, or there will be some API to create Kubernetes cluster, these kinds of things. So there is no need to actually talk to these people. Instead, they provide an API. And then there is something maybe like the architecture, so that's an enabling team, and they would facilitate what the other teams are working on. So they would help them with architecture questions, or they might even collaborate. So that is something that can be done for a short period of time. And during that short period of time, someone from the architecture team would, for example, join one of the streamlined teams to work on a very specific topic. And this is basically all there is to team topologies. And I mean, obviously there's more, right? There is a book with over 100 pages, and I've done a stream about team topologies, which took an hour. But it's not that very complicated. It's 3 forms of interactions. It's 4 team types. And the challenge here is these are magnets. So the idea is, so I think the problem that we have with a lot of these approaches is that somehow people think, well, we are going to draw this org chart, and now things will be different. things won't be different just because you draw an org chart. You somehow have to work on the organization and actually make people collaborate, right? If the architecture thinks that they should control the teams, it's not going to work out, right? They are not enabling the teams, they are trying to control them. So therefore, it's important to bear in mind that these are magnets and work on that. Let me just, okay, so here is the link to the episode that I did about team topologies. I'm afraid it's in German, sorry about that, but there is lots of English material at teamtopologies.com, I think, like really, really good material, and you can definitely look it up. There are a few questions, so let's see. Core domain Wortley mapping. Wortley mapping is a technique with which you can understand the domain and the competitive landscape. So yes, this could be a way to come up with the core domain. Then how would you create team topologies in small teams? Is it more important to have business teams or specific technical teams? So I think there is first of all, let me say one thing. Sort of by definition, this is about, this only applies at a certain scale, right? So if you're just one Scrum team, there is no way to do team topologies, and you shouldn't, because you're just 5 people, so, or 7. This is about how teams interact. Now the real question is it important to have business teams or specific technical teams? And that's actually a very good question, and the answer is it's all about the stream-aligned teams. So what team topologies quite clearly says, in my opinion, is that you should have these stream-aligned teams. So in our example, this would be invoicing, order processing, and delivery, and the others are just there to help. And I mean, in a way, it should be obvious, right? Because these stream-aligned teams are the ones that actually create value, and the others just help. Just is probably, they help, but they are supporting the other teams, and I think that's clearly the focus of the whole thing. With team topologies, where are the stakeholders, e.g. architectural governance of technology platforms to use, e.g. Java instead of .NET, etc. Architectural governance. It might be outside, right, because it might be something that the whole organization does, like on the corporate level. And as I said, how shall I put it? In the ideal world, you would rather have the architecture focus on supporting the teams, right? And therefore the question to me becomes, what's the value of architecture governance? And you somehow have to explain that to the teams. And that's also probably one of the reasons why it's important to keep in mind that these are magnets. So in real life, you might need to make some compromises. For example, because there is architecture governance and you somehow have to deal with that. So what I'm saying is that maybe you can't do this as it says here. Maybe you have to do some compromises, and I think it's good to be open about that and clearly communicate that. Okay, so what now? Well, we are finally doing coding, even though I'm afraid it's only sort of coding, because I'm not going to show any code, sorry about that. So we are going to be a little more concrete, and the next concrete thing is tactical design. What is it? It's object-oriented concepts which actually make a lot of sense, in my opinion, to build good object-oriented systems. So how does that work? Well, there are quite a few patterns, and I've put them in a hierarchy. So stuff in the bottom can be used from stuff above it, but not the other way around. So it's sort of layered. So the first thing is are entities, and entities are something that have an identity, right? So I'm me, even if there was another person that has the same name, the same birth date, and lives at the same address, it's a different person. So I do have an identity, and entities are things that have an identity like a person. We are building object-oriented systems, so therefore these entities do have business logic. That's actually the point of object orientation and also of tactical design. So there would be something here that can, where I can figure out whether I'm able to pay something or whatever, some kind of logic. And then there are value objects, which are values, like 2 euros, 2 meters. So 2 meters are the same as any other 2 meters. It's just the value, while someone who has the same properties as me is still a different person. So that's the difference. And then there are domain events, which we sort of already spoke about. So something that matters to domain experts that happened. And that's basically the idea here. Then we have aggregates. And aggregates are composed of entities and value objects. And they ensure consistency. So they are sort of a gatekeeper, and the gatekeeper says, okay, all the entities, all the value objects should be consistent. And then we have repositories, which give you the illusion of a collection of aggregates, which are then probably stored in a database, but might be somewhere else. That's hidden from you. And they have specific ways of accessing that collection that fit the requirements. So no generic query interface. Factories to create complex value objects and aggregates. And then finally we have services. Services are the objects that contain the logic that doesn't fit in entities or aggregates. If you have something that deals with more than one aggregate, so for example something like a delivery process probably deals with customers and a delivery and products and what have you, then you have to put it somewhere. You can't put it in an aggregate, so you have to put it in a service. So that's basically the idea. I want to point out that there are alternatives, in particular for less complex systems. The reason why I want to say this is because if you make some architectural decisions, like in this case use strategic design, then you should be aware of what you're not doing, the other options that you could have taken. And one option is transaction script. Transaction script basically that's from Patterns of Enterprise Application Architecture by Martin Fowler, and it's basically well, I think it's a good name. It says that if you do something on the UI, if you have some HTTP request, a script will be run that does something on the database. Which seems like a pretty stupid idea because you don't even separate UI, database, and so on. But Martin wrote it, so it has to have it has to make some sense. But quite honestly, it is something that is very, very simple, and that is easy to follow and easy to understand if you have very simple logic. If you just want to copy data from A to B, if you just want to add something to a database, maybe this is what you want to do. And there is something similar, which is the table model. So in that case, you have a single instance that handles the business logic for all rows in a database table or view. Again, you can see that it's database oriented, right? It clearly says we are using a model that is very tied to the database. And I think, I just had a discussion somewhere a few days back. I think if you are about to use this model, you should ask the domain experts what they want to do. And why, what is going on there. So one example might be, okay, I want to see this information about the customer. Okay, why? Because I want to figure out whether I can deliver him anything. Depending on the address, depending on whatever his status, is that a person that we want to deliver stuff to? Now we can have a discussion about business logic. So something that used to be a very simple thing that says, okay, this is what we want to display. This is the data that needs to display. this now changed to a discussion where we are talking about business logic, and this is something where technical design might make sense. While the original requirement would be something where I would probably use something like a transaction script, right? So HTTP request comes in, take the data out of the database, display it to the user, done. And this is why, how shall I put it? If you are writing that stuff, I would try to figure out whether you're really doing the correct requirements or implementing the correct requirements. So in the example, we would have maybe a parcel, which would be an entity, right? That is something that I can identify. We would have the address, which is basically a value object, and they might be part of an aggregate like the delivery. And for the delivery, we might have a factory to create this complex object. We might have a repository about all the different deliveries that there ever were. We might have an aggregate like a customer. And then we would have something like schedule a delivery, which would be a service, which would probably talk to the customer and the delivery. So therefore, that logic cannot be part of either aggregate, but it has to be somewhere else. And then you could have an event that says, okay, a delivery has been scheduled. I did an episode about this. Again, I'm sorry, in German. There's also a sketch note about this episode. How do I support this? From a technical perspective, there is this idea of plain old Java objects, right? And this is probably what we are talking about. So simple Java objects that somehow are persisted, for example, using JPA or something like that. There is the library called Xmolecules, which supports DDD concepts as first-class citizen. This might be something that you want to take a look at. And there is also a blog post by Oliver Drutbohm about describing about this idea and how to work with this. There are a few people who argue that you shouldn't, or that this is framework agnostic, and I would agree. You know, the concepts are framework agnostic, but still nothing prevents you from having something that supports you in this regard. As you can see, at the end of the day, we are, you know, services should probably use aggregates. Aggregates should use entities and value objects, but not the other way around, right? So there are specific dependencies that you can figure out. And also between bounded contexts, you can figure out specific dependencies. So the order process will probably use delivery and invoicing because it has to forward the information about the order, but not the other way around, probably. And this is where architecture management tools come in. So those are tools that you can use to support these kinds of dependencies and manage them. So that might be something that you want to look at. And I did quite a few episodes about this. There are a few English episodes about specific tools. So for example, about Structure 101. And this is something that I would encourage you to use to enforce this kind of architecture and the dependencies. Actually, I shouldn't say enforce, right? It's about, you know, taking a look at the code, making sure that it conforms to the architecture. And if it doesn't, either someone didn't understand the architecture, which should lead to some kind of communication, or there's a problem with the architecture, which should also lead to some kind of communication. So it's not about enforcing, it's rather about facilitating communication if you do it right. So a problem in the dependencies should lead to some kind of communication in that regard. In conclusion, so I've spoken about quite a few of different techniques. So I started with big picture event storming. That's like the big brush, right? Like the whole big picture that you're painting there. And then I spoke about core domain, about the focus that you want to put. and probably something like strategic design, which you probably don't want to do. You probably want to do team topologies instead, as I mentioned. Then we spoke about bounded context, and inside such a bounded context, like the delivery one that I've shown, you would do tactical design then. So that's sort of all the techniques that I've spoken about. If you enjoyed the talk, here's an email address. If you send an email address to that email, then you will get a link to a Dropbox with the slides. There is also a direct QR code that will lead you directly to the, I'm sorry, it's actually not a Dropbox, it's a OneDrive. And then there are questions down there. And the email system is powered by Amazon Lambda, and it's a small microservice. So if you use that email system, then your email address will be locked for 14 days. I'm not using it for anything else besides sending you out the slides, or the script will send out the slides, and that's pretty much it. When does the next talk start? At 10. Aber wann ist denn die Keynote?
Bitte?
Keynote?
Die ist, glaube ich, nicht hier. Also hier ist jetzt das
Okay. So here is what I suggest. I'll take 1 more minute at least to answer any questions. So are there any questions? Anyone who wants to ask the question in person? There are none in the internet anymore. No questions? Excellent. Okay. I'm going to stick around here for, I guess, until noon. So if you want to catch me, you're more than welcome to do so. I hope you enjoy the rest of the conference, and it was great to have you here as an audience. Thanks a lot. And thanks a lot for the questions there.